Hello, just put my microphone on, might be a bit better. So today we're going to look at the BUSSide code and do some development on it. We're going to add support to Flashrom. I'll just wait a few more minutes while people enter the chat and then we'll kick it off. Just waiting for some people to enter the chat and then we'll kick it off. I've not tried any development streaming in the past. Hopefully it comes out okay. I spent a large section of my career as a developer, so hopefully this isn't too bad. Can you hear me on the audio okay? Okay. Okay, great. Let's kick it off. So the main plan for today, like I said earlier, going to add Flashrom support to the BUSSide. I've already done an initial implementation of Flashrom support a couple of weeks ago, but in that period of time I did a lot of changes to the serial communications between the Node MCU and your laptop or desktop over that serial communication. So I have to rewrite that code. And I also want to add some extra support to the BUSSide directly so that it can do some more optimal SPI command processing. So I think the first thing that I'm going to do is I might add I'll add support to the BUSSide first to support this extra command, which will make the performance quite significantly better. So let's go into the Flashrom code. Let's have a look. Where is it? It's been a few weeks since I've looked at this, and like I said, I added initial support to the BUSSide. So basically we end up with this. The core part of Flashrom is that it can do most of the work for you. You just have to set up a part to do SPI commands directly to your device and your flash memory, and then it will coordinate all the commands like read and write and so forth around that. So this is the original code that I had making a request to the BUSSide, but it's a bit slow. It's not really very good. So let's add write count, read count, write array, and read array. So let's go into our BUSSide code. Okay, we're going to add an extra function here. Define BS SPI. We'll call it fast send. SPI fast send 43 44. So this is how you add support to the BUSSide to add some extra commands. So let's find our, where is it? SPI send. Let's change that to this. SPI fast send. Send SPI, we'll call that fast command. Now we go into our, where was it? be here somewhere. SPI send command. Oh, okay. So we've got. I forgot I've actually got a Bitbang implementation and a non-Bitbang implementation. That's fine. So this will use the Bitbang implementation, and the reason for that Bitbang implementation is that you can have non-hardware supported pinouts. So let's send in SPI fast command. Okay, let's increase. I've just been told that I need to increase this font size. Let's see if I can do that. Preferences. Let's do it to 16. Is that a better font size? Okay. I'll just check. Like I said, this is the first time I've done development streaming, so I'm not even sure if people will find this interesting, to be honest. But we'll see. Let's have a look. Just before we go on, I'll just check with you guys to check that the font's okay. Yeah, I'm just going to go with that font size. If you want a bigger font size, definitely just message me on the stream and we can increase the font size. Okay, so let's look at what we've got here. This is our, where did we go? Our hardware sends our fast command. I'll just check that I called that the right thing. Actually, some of this this font size is actually causing issues with it's not printing them correctly now. Let's see if I can fix this. Let's change it to 15. Preferences 16. We'll go with that. Send SPI fast command. Okay, so let's get underway. The fast command is going to take. We'll call this right size. And then we have our. Let's call this a read size. Then we're going to have our right array equals. What did I do up here? Command size. We'll fix that up in a sec. So the reply is we need to allocate for our header size and our read size. Reply data is that. Command equals this. We're actually going to change it to use what are we going to do? We'll change it to use a char array. And we'll do this as request 7. Allocated on the stack, so we don't need to do any cleanup. What have we got? Let's go command data. What did I have as data before? Just curiously. Data equals. Sorry, did I delete that? Oh yeah, I see what I did. So this just needs to be, let's call that data. Change this to data. Unit 32. We have our write size, read size. So this is writing some commands to the SPI bus, specified by our command, which is down here. And then it's reading stuff. And this needs to be read size. And we can get rid of that. And the payload length should be read size. Okay. That's the firmware support that's needed, I think. Let's just check read size. Apply. Data. Oh, okay. There is a couple of extra issues here. So let's do send fast command. Let's call this reads write size. BB fast. That was send BB. This is it here. So okay, so this isn't. I'm not convinced this is great code. It's super redundant. I mean, right size. Well, it's changing that. We'll change that to out in read size. So we're going to do for I is write size. Yeah, I'm not convinced this is great code, but I mean it solves an immediate problem. Probably some technical debt here somewhere, but hey, let's, and then in, okay, in and out, and that just has to be 0 now. Send BB fast command, so out and write size, in and read size. Let's go back down here. So let's just check out and write size, in and then read size. Okay, that's good. Let's just compile this. Okay, what have we got? Send SPI fast command. That's because I haven't declared it, and again it keeps on screwing up my font under rendering, so I might change that to 15. You can tell that no one changes the font on these things. Where is it? Send SPI command. It's sort of a bit messy code. I mean, it's not super pretty code, I'll tell you that. The text in the bottom right window is ineligible. There's the font size. Just someone commented saying that it was ineligible. I can increase the font size again, perhaps. Let's see if I can increase it again to something ridiculously large. I did all that code as well, to be honest. Well, not all that code, but I did a fair bit of code. So let's have a look at where we are. Where did we go? Is that a better font size for that screen? To be honest, that's pretty much all the code I'm going to do in that screen for now. Unit data. Where are we? Here we go. Yep, let's remove that. Let's compile that again. I'll flash the firmware shortly. Cannot convert. So we've changed that to Uint 8 now. Let's compile that again. This is definitely a trial by a bit of trial and error to get this streaming nice and smooth, so that people can actually read the font. Looks like it's compiling. Let's go into our. Let's have a look there. Okay, so BUSSide SPI command. So there we are. So what did we change this to? Every time I change bloody things, it screws up the font. So 43, I'm going to change that to 43. BUSSide SPI echo. Okay, so command length. We've also changed the format of some of this stuff, so that is all changed now. Let's see if I can just copy this. Yep. What do I call this over here? Frame. I apparently still can't read this font size. But we're probably not going to use that code anymore now. I mean, there wasn't a lot of changes to make, but we'll go with that. Frame. Yes. And we're gonna. I mean, this is sort of not good. I mean, this is just this is like terrible hack, but whatever. Okay, so let me just go into Flashrom code. What was it called? BUSSide. So, okay, so we've got a request here. So this is the request reply. So the format has changed, that it's, may as well change it there. I'm going to make this a that. What have we called it? BS command. We've got command. Payload length is the new name for it. Payload length equals the write count. We also need to do request equals struct BS frame. So allocating space, BS. I haven't declared that yet, so I'll have to do that up here. Let's do, oh, define BS header size. How many fields I have? I have 1, 2, 3, 4. We'll call that sort of a hacky way of not using size of. I mean, that can lead to problems down the track. Right count. I'm not quite sure how you return an error here. How do you return an error? So it's an int for a start. Let me look at here we go, error OOM. How do I get to here? BUSSide echo. Error OOM. And we'll use squiggly braces just because I don't always use them. We need to change this to a pointer now. Okay, now we've got our arguments. Okay, I think this is so this is the pinout for the hardware SPI. So I'm just sort of what we got up here. So the 5th argument is the write size, and the 6th argument is the read count. Okay, we also need to yes. So let's call request data equals uint 8. Actually, I'll just do a mem copy. That's probably the easiest way to. I was going to do a loop to copy it, but let's just do mem copy. Where are we? Request BS request arg7. That's our destination, and our source is write array, and then we have write count. Okay. We have a lot of, so we're going to do the retries. Let me look at how I've done this in the Python code. BS. Because the Python code works pretty nicely, to be honest. I'm going to connect to the device. Okay, so we have a couple of new things. So there's the new synchronization. This font size is quite awful. So we're going to do unsigned char. Let's just see if it does this. So we're going to send our synchronization word. And okay, so that's okay. Our sequence number is okay. We need our length. That all looks Okay. Nah. I have to create that to 0. Yes, checksum equals. I'm going to increment our sequence sum. So that's a slight change from before as well. We're going to have a sequence sum that increments on retries. There were some cases when it could have caused some problems. Command length. Okay, so we're going to write our request, which is a pointer. Need to change this to BS header size plus right count. Why was I doing -4? I think it was the checksum maybe. Let's change that. I'm not very good at explaining what I'm doing, to be honest. I'm probably better at that other thing because I'm sort of just coding as I'm going. Okay, so we've created our. So initially we initialize our checksum to 0. Then we calculate the checksum with that 0 with it as 0. Then we take the checksum, we write it. Let's move our what did I? Damn it. Let's move this to be next to our right. Let's get rid of this. Should we do that flush incoming? I don't know. Yes, header size plus right count. Well, actually, if you think about it, we actually we don't need to do this mem copy. Maybe yeah, that's actually because we can do it in 2 separate writes. But we have to calculate the checksum, which makes it more annoying because it's a sort of a. Okay, we'll just keep it as that. We'll just keep it as that. So now we've sent that. Now we're going to add a BUSSide sync. This is a sort of a new part of the. Actually, we don't need this because we're not doing synchronization. We do it on the firmware side. Let's have a look. That's all good. Build frame. We write it. We do a flush to outgoing data. Okay, let's read our serial port read non-block. Reply. Let's just call this header. Okay, it's not. I mean, if you were writing a network stack, you'd probably want to make, avoid these copies. But for us, I mean, this isn't the limitation of the performance. So reading the header now. Go to error. Let's add our. Where's the error? N equals that. Let's do free request. So we can just free it up. Free request. This is sort of. I mean, that's a sort of a weird sort of style, but. Let's just get rid of that. Free request. So our reply might be reply might be different. Request. Let's just go to here. So we read it, we read the header. Okay, at this point we're going to allocate malloc bs header size plus reply, oh no, header, sorry, header dot bs payload length. Error OOM I'm going to do a mem copy of our header into our reply. We'll just keep it as BS header size. There's some style choices here. Do we use size of or BS header size? I'm sort of 50-50 on these ones. Okay, so let's add reply. We need to add it before here actually. Just some sanity checking. There should be a define. It's a bit go to error. Already see what sort of potential memory leak here. Okay. Now we're going to check the sequence number. Okay. We need to make a copy of the checksum, which is, let's do it into reply now, bs checksum. Now we make checksum equal to 0. Get rid of that and because we've changed it from a structure to bs header size plus where was that bs, was it reply, bs payload length equals checksum. Let's add a type here. Okay. Is that all we need to do? Looks like it. Looks like it, yep, that's good. So error we should free reply. Make reply equals to null. It's not, it's just defensive programming. Got a sleep here as well. We can probably get rid of that sleep. I think it's a bit better now. Free request reply should be taken now. What does reply have? We still need the reply. Read count. So now we need to copy back into our read array our reply bs payload. Let's just keep it as bs payload. And our read count. We can actually do, I've just realized that there's actually an optimization that we can do. Here. So if header dot bs payload length does not equal read count. How's that? It's a bit easier, isn't it? I'm just going to keep that in there just as a safe. Well, I'll get rid of it. It's probably okay. So that's good. And I'll probably allocate this memory a bit early on as well. Let's go up to here. Put that in here. We actually do know the size of it. I'm not a big fan of rewriting code. It's actually bad that I didn't sort of think of this already. In retries, we're going to send it. We can just read directly into reply now. We don't need header anymore. Read into reply. Does or n does not equal yes header size plus read count. Get rid of this. That was wrong anyway, to be honest. Now we're checking for the length, checking for the sequence number, copying the checksum. We'll keep it like that. Go to air. Flush incoming, free request, free reply. Copying it into a read array. That looks pretty good to me. Now, I reckon that should work. It's not as it does in this code in the Python client. It does a reconnect to the serial port. Let's just keep it without it for now. Okay, I've got to fix up this echo as well. BUSSide's echo. I don't know what that 10 and 2000 are. Built. Can't remember what these arguments are. So the number of retries and the timeout. Okay. Right count, that looks good. That's sending the command. Got to do that echo. Basically, we just have to replicate all that code, to be honest. Okay, let's just repeat it all. Is this technical debt because I'm making redundant code? It sort of is. Yeah, well, it is actually. So here we go. BUSSide. Was it echo command? I just got a message to say, why not use defiance for those timeouts and retries? And yes, absolutely right. So this is definitely the accumulation of technical debt. It's like, oh, I'll clean it up one day. I'll definitely clean it up one day. So payload length equals 0. Echo is pretty simple from memory. Let's just have a look at sending echo command. Let's just have a look at the code for echo just to make sure that I'm okay, there is echo, so it's not, so yeah, I just remembered, so BUSSide doesn't need any of these args. Let's just check that I'm in the right file. Doesn't need any of these args. Doesn't need that. Now sure, I could optimize this. Yes, header size. Okay. Probably wondering about brackets a bit. Yeah, let's get rid of that bracket. Sequence number. Payload length. Yep, get rid of that. I think we're done. Okay. So let me just flash the firmware. Hopefully it came up, detected it, yep. Flash the firmware there and I'll build this code here. There will be errors, I mean there always are errors, I mean there has to be. We get BS request args, okay. Request args. So there is no request args anymore. So let's just change this to always have mistakes when you compile it. It's actually very rare to compile after a refactor and have it all work. Probably says something about the software development cycle. I'm looking at request BS payload. Is there a reply args as well? No. Where do we go here? Wait, that mem copy. Oh, what's wrong with that? Oh no, thing called request args. Different signess. 110. There we go, and our serial write. What was it called? Serial write. Oh, let's be fancy. BS sync word. Very fancy now. Should be one more for the echo. Should be one more. Here we are. Actually, if I do size of, that won't be good. Let's just call it 2. Not good, but I just want to get it to work at this point. Let's go into static unsigned char bs sync word equals, what was the sync word? Now there is a slight problem with this. Yes, sync word. Okay, so it compiles. There is a slight problem with the sequence numbers. Let's think. I guess we should fix it. Sequence number. Next. Okay. Let's do, okay, so static void bs next sequence number okay. So now we want to do fd equals open bar temp BUSSide.sequence number. Right. Sequence number, comma, size of bs sequence number, close fd. Hope there isn't an error with that writing to file. Might need to add a few extra includes. It's all looking non-fcntl.h. Okay, so there should be an init function here somewhere. Here we are. So let's do that. Let's do fd equals open let's do that. let's move all this code into its own function. Let static int BUSSide sequence number init int fd let's change that to yes sequence file. Let to bs sequence number init. Okay, let's go into if so sequence numbers are useful for us because we use them in the serial communications protocol to avoid duplicate packets or duplicate frames. This serial driver that this node MCU uses actually does do duplicate frames randomly, so you really do need to have that. Let's do define BS. See, I've used BUSSide and BS. That's generally pretty bad form. Let's just line up all of these. It's really personal preference whether you tab these in or not. On systems with different tab sizes, it sort of can cause problems. Okay, let's make that again. And that's the, there we go. Okay, that's that. So we've, I think we're done. So let's test. It'll probably not work. That's the expectation, to be honest. Flashrom, use P, as we get how to do this, BUSSide, dev equals dev tty USB 0. How do you run this? Valid choices are BUSSide SPI. Okay, so I haven't connected my BUSSide to the VM. There we go. So now it's connected to the VM. There we are. Unhandled parameters. Let me just look at the man page for Flashrom. Dev equals minus P. Yep, that looks alright. Unhandled parameters, that's sort of interesting. Let's just do this. So where did our initialization fail? Yeah, so I did it the right way. I must have some errors up here. So BUSSide spi.c sequence number init, let's check that. Here's probably the problem. it needs to be read. How do we open and create a file? So we need to do create. If n does not equal sequence number, then let's assign a sequence number. Let's call it 5, or maybe call it 2. That'll be fine. Should have flags to specify the. Okay, let's have a look. There we go. So what am I doing? Let's add verbosity. How do you add verbosity? Minus v. Might be trapped in that echo. I'm going to unplug it, plug it back in. Try it again. Does GDs do anything? Okay, so now it's not working. That's okay. Let's go to our init. Check. 04 setup. Let's for a start add let's add for a start. Let's add some printout. I, comma, n retries. Add it there as well. Try it again. Got trapped. Let's see if it created that temp. Didn't even open it. So where is it getting trapped? Sequence number init. Let's just use ltrace to see if we can get so it opens the serial port and it writes to it. Why did it create that that serial port file? That's odd. Did it make it there? If BSC sequence number init.
Let's just go into ending it to verify that that it reaches this part. It should. I mean, it should get to there. I don't see how it cannot get to there. Well, let's just not use. Oh, I mean, bus pirate for bloody hell. There we are. Oh, it gets there. Let's L trace it. Okay, so yep, so it's in the initialization code. And this is our problem. Why did that not open it? Let's fix that up a bit later on. Read. Okay, I think I know the problem here. So let's do. This is what we want to do. We want to write fd. We want to write our sequence number to the file. And we want to return 0. That's good. Debugging is absolutely part of every project. There we go. Retrying. We had some problems there. Let's L trace it again. Get a free, so we hit the retry, so we didn't clean up for some reason. So it must be an echo. So our request is good. Command echo payload length. Let's just check down here. Oh yeah, hit this free request, free reply. Where did we go wrong? We allocated space for it. We wrote our header. We read our header. We checked our checksum. Did it make it? Let's just check that okay. What have I done? Right. So got the echo. Oh no, it didn't get the echo, so it made it to 9. That does not look quite right. So the actual problem is in the request reply. Looks like we got a double free. It's probably not a good thing to do there. So let's free request. Where do we go? what do we do here? Where do we... Free request, free reply. Is there a free somewhere else here? So we must have a overflow somewhere. Replies, right count. Oh yeah, here's we have a very nice heap overflow. A very nice heap overflow. BS plus 7 times. You know, you'd be surprised at you'll be surprised at how often these things occur. I will tell you that. We want to return -1. We do. Nice heap overflow. Doesn't fix actual, you know, the functionality. It still won't work, but we won't get a. So it's in a loop. Keeps on retrying. That's interesting. That doesn't work for a start. So the echo doesn't work. So let's just check if 0 return -1. That'll fix the initialization, hopefully. There we go. Now why isn't it working? Let's go into echo. We put our, is there a flush command for serial? There's flush incoming. SP flush incoming. Let's just assume that it flushes it. Probably doesn't. Okay, so let's figure out why we can't. Well, also let's I mean, this is going to sound silly, but let's just actually verify that okay, now this is interesting. This means our firmware has some problems. I don't think our code, this is the client code, so it looks like there's some firmware issues here. Done uploading. Let's just check this loop. Let's just plug it out and plug it back in and actually see if it... Okay, so yes, that worked. So let's just check it again. SPI, flash, read ID. Yep, that works, so it does work. For some reason it got into some weird state. Okay, so let's look at our code again. What do we need to fill in? We need to fill in, let's look in the echo code. BUSSide SPO echo command has the payload length, the sequence number, and the checksum. One, the sequence number has to be higher than what the BUSSide boots up as. So if we look at our BUSSide code, let's just see what our sequence number is set to. Sequence number is set to 1, so that's okay. Okay. Okay, so this is all little endians, so we don't, if we were doing multiple different architectures, we'd have to figure out the endianness for stuff. We've got the checksum, sequence number, payload. Let's just check it. Command, payload length, sequence number, and checksum. That's good. We write our request. Okay, this is the problem. No, oh no, it's not the problem. That's not the problem. This is the problem. Payload length. Definitely it's meant to be 0. Okay, let's try that again. I think it got past the echo then. It got the echo, so it just didn't get the SPI command to work. Okay, let's look at our firmware. Could be multiple issues, I think. Let's have a look. Read size. Okay, that looks okay to me. It's setting that correctly. I suspect it's another of these SPI command. So write count. That looks good. Is it going to be? We've added the request, which is 7 plus the write count. Payload length, here we go. So it's again 7 times size of uint 32 plus the write count. If only development didn't have, there we go, echo OK. So it's definitely doing something. It's much slower. So I suspect it's reading in serial now. Let's have a look. And the problem is, I bet payload length. That's good. It's this here. Let's just change. Let's add an extra reply size. Let's call reply size equals BS header size plus 7 times size of uint 32t plus write count. Request size, sorry. This weekend's a long weekend for me. I'm going to go over to Kylie's house shortly, just at the warehouse at Infosec right now. We have a couple of wines this afternoon. Maybe cook some food. So, okay, so payload length. It's so stupid, maybe we should just leave that as, oh, let's get a request size minus BS header size. We want to change this right to request size. Here we go. quietly confident. Nope. Damn it. Thought that was it for sure. So let's have a look. Yes, header size. Request size is better. Did the checksum. Oh, here we go again. Another one. Request size. Calculated the checksum incorrectly. Quietly confident. Now what's happened here? What is that? That's very odd. Got into some weird. More. I should use the tiling window manager. Yes, I should. Flashrom. Minus P, BUSSide, SPI, dev equals dev minus P. Okay, so we still get retries. Request size. We write our sync word. Let's just see if we get our N and let's write our payload length and our read count. These should all be the same. If they're not, then something's gone wrong. Now that's interesting. Our payload length is 4. And N is 16. Has it added an extra? Yeah, because it's okay. So, no, that's okay. So, the payload length is 4. The header is 16. Okay, so why don't we, for a start, just split this up into 2 things. So let's do payload 0. I'm going to do that as a read count. Get rid of that. Get rid of that. Okay, so if N does not equal BS header size, okay, so now we're just reading the header. Okay, then we read, well, let's read our payload for a start. Reply BS payload. We really need to do a check here to say if reply BS payload length does not equal read count, go to error. We really should flush incoming here as well. We do that, so that's okay. Now we read that. We do a read count. Let's just compile it. It might not, I don't think it'll work, but we'll compile it and maybe we'll just we'll lock out and it will work immediately. What do we got? 3s unsigned char. What am I doing here? What are these two things? Yes. You want to do yes. Let's do recount. Recount doesn't use a dereference, so technically it's fast. Okay. Here we go. That's good. And it worked. Yay! We got the first the first part of it worked, so let's just get some rid of these things. That's much faster than I was testing it the other day. Okay, let's run it again. Must have fucked up that sequence number. Ugh, so annoying. Let's do it again. Okay, so I got out of sync. There we go. That's working pretty well. It's detecting the flash chip. Oh, so okay, so that's pretty good. So now the test is how long does it take to dump? Like, well, does it? Okay, so there's a couple of things I have to do now. So with the new code, there is actually some seriously there's a static definition up here. So there's definitions somewhere. Maybe it's in this one. Where is it? Let's go to BUSSide. Flashrom.c. Here we go, BUSSide.c, max data read. And we can actually extend this now. This is the new code. So let's extend this to 2048 and max data write. Let's call it 2048 as well. And this will change our block size that we're doing. So we should see improvements. It shouldn't affect this thing, determining the flash chip ID. Okay, so let's time how long it takes to dump an 8 gig flash. Actually, it doesn't. I always think to myself, like when I use the BUSSide client code, I have to put in the size because I don't do the chip ID to size. But let's out.bin, and this is probably going to take about 5 minutes now to work. Oh, unless it fails. So that's not good. Why did that fail? So got read operation failed. Try it again. Did a few retries then, but that's okay. I might need to put some timeouts in when their retries are occurring. Yeah, so I think it's a retry issue. I probably need to put in a small sleep. So let's just check. Let's just check. To be honest, almost there. This is just the final sort of parts of it now. We do the mem copy printf just to see that we are getting the right function. Yep. Just to see that I am getting. Okay, so it's a retry issue. Wait up, let's see if we get through this part. Yep. So there we go. So we have some slight issues there. Let's add a sleep here as well. See if that improves it. It's reading 2K blocks at a time. Now, in the client code for the Python BUSSide, I do a reconnect of the serial port if it. Okay, so there we have some problems. Notice that it retried the first one and then it slowed down really. Then it did the other ones really fast. So why did that happen? Next sequence number. I don't close the serial port anywhere. Actually, you sleep for 500. Yep. Let's extend that to 5,000. It'd probably be nice to add some printfs to say what type of error it occurred. Like, was it a checksum failure? Was it the number of bytes wasn't read, or a duplicate packet? Now that's interesting. That's interesting. Is it the read? Did it read? Why isn't it doing that? That's very interesting. Let's just add a printf here. Zero is success, 16 is the number of bytes read. It's reading the header at this point and not showing the rest of it, but reading the header. So here we go, got the header. We did get the header, so I suspect, I think I know what's happened. I think I know what's happened here, maybe. Command pay length. Okay, so I've got the header. Now let's print. Okay. In comma. In. Okay, I think I know what the problem is. No, I don't. No, I don't. Let's do checking sequence. Checking checksum. Okay. That's all good. We get an error soon. All those print tests have added some delays as well to the reading of that serial line. So that potentially has improved the reliability. Here we go. So what did we get? Okay, so here we go. Got that. So the payload length is wrong. At this point, we probably need to do. Okay, so there are some reliability issues, and I think the problem is I'm only doing synchronization in one direction. So I'm going to, let's do sync. Okay. Okay. I'm going to do static void BS sync. And this is going to be similar to the BUSSide code. We'll just copy that directly. Here we go. Now this is sort of interesting that you can solve reliability issues of a communications protocol by better programming, not just by getting better hardware. What was that? Okay, so now we want to write serial. I'm going to do this. What are we going to do? Do a serial port read, a blocking read. I think I'm not quite sure what the API for this is. Serial port read. Okay, so it doesn't do that. And all we want to do, let's just do if serial port does not equal 0, continue. Did I do 2 here? So continue. We put this down here as well. There we go. So now we need, any time before we do a read, we do a BS sync. This is the echo. Okay, that's good. And now we have to reflash the firmware. Send reply. Do a serial. This does of course mean now that I have to fix up all my other code. It's sort of annoying. So let's go into 8. What was it? FECA. FECA, comma 2. We'll do a flush. Okay, so underscore T. Pass this back to the. So this is basically adding a synchronization word, and the idea is that at the beginning of a frame you get a synchronization word, and if you don't, you just keep on reading data because you're assuming that there are stray characters on the serial line at this point. You keep on reading data until you get that synchronization word. And this hopefully syncs up those errors. So hopefully this resolves that last issue that we had. Okay, so return it back to my thing now. Let's just see if it works at all now. So let's not read the flash, let's just read. Didn't work. This adds a synchronization to the reply. FECA. Let's add look. BS sync. FECA. Okay, I think I know the problem. It's because the echo is using that's okay. That's okay. Send reply, so we're definitely doing that. The output does not equals 1 is what we want. Oh, that's interesting. Yes, sync. I need to make this unsigned char. Use variable RV. Why haven't we done this? Let's just go and declare our function prototype. Let's use static void ps sync. There we go. Now will it work? We must be getting trapped in that sync. So annoying. Probably need to use non-block. One. Oh, there's this. Oh, let's have a look. Let's sync 1. Let's sync 2. Let's have a look. I'm going to repeat it. Okay. Let me just check that I've done this right. Are we in the echo or are we in the... Reboot it again. It's still in the echo. Where is it trapped? We actually programmed it, didn't we? I did program this, didn't I? I thought I did, but let's just make sure that we've uploaded it. It looks like it was uploaded. FEC8, that looks good. Let's just upload that again. Okay. Let's go back to our program. Let's see if we get anything. What is it doing? There's not another BS sync anywhere in here, is there? FECA. What does serial port read? Serial port read actually return. Okay, it returns 0 on success. Oh well. But it returns a number of bytes. I suppose it's blocking, so it either succeeds or it doesn't. Let's just try that again. There are some limitations to this code. It does, now is the potential for blocking. There we go. So that worked by the looks of it. Let's just run it again to see that it detected. Don't want to run that. See if it survives. Okay, let's go to Win. Found Win1 chip, that's good. Minus R out.bin. Now with synchronization. Does it solve a data comms issue? Here we go, retry. And it got past it, okay, so it survives retries now, it does, it synchronizes well. It was very quick, so I mean, if you, it actually went into a retry loop, and it only did it once, and then it resynchronized and it worked. So I think that has solved it. Here we go. So there's a resynchronization issue here. Nope. So it got stuck. It read all the data, and it lost the synchronization bits. So what does that say? It means that we have to use non-blocking up here. Non-block. Timeout and N. And this will actually fix that potential of block, non-block. Let's change this to, what was that N and was it timeout? Let's go to timeout, N. If N does not equal 1, continue. Int N. Timeout is the first one. Non-block timeout, N. If N does not equal 1, does not equal 1, continue. So basically we want to do a timer here. I'm going to use day. TV start, TV current. This is very Unixy, and time null, TV start null, 1 day, TV current null. Sub TV start, TV current, TVR. I'm going to add a if TV is greater than TV sec is greater than timeout. Turn -1 equal to timeout. me add this down here as well. That's okay. We'll leave like that. Okay. I'm going to add timeout. And -1. Return 0. BUSSync. BUSSync. Timeout of, let's make it 2 seconds. Oh, let's make it 3 seconds. It includes this time. This is a very portable code. What have we got? Oh wait, we need to add BS equals 0, go to error. It's just insane the work that is required to get these things to be reliable. I mean, it's just insane, literally. The amount of it's like re-implementing, X modem and Y modem and all of these dial-up things. Here we go. TBR. Let's call that result. Let's call it a diff. Okay, so now let's run it. So now basically, okay, so that didn't work. Let's just unplug it back in. Let's see, it should work. I don't think it's a big amount of things. So okay, so there's obviously that sync is not working. Got sync 1. What is that? Your serial port. Let's just check the errors conditions. Okay. Got sync 1. I've got sync 1. Got FE. What does it say? Return -1. This is the problem here. Do if n does not equal 1, this is timeout. Wait, what do we got that time? What is this timeout? Oh, of course, here. There we go. Give it a try. Let's just try it. reading flash. Waiting for an error. Yeah, I'm just completely always surprised. So, okay, so now should be a timeout now, and it should retry. That was a very similar one to the last error. Why hasn't that retried now? So it's trying to sync. So it's trapped here. Why is it trapped? Got a does read non-block. Is timeout in seconds? I have no idea. Read non-block. Timeout. Timeout milliseconds. Read. Okay, so it tries up to it's in milliseconds, so why hasn't that worked? Got a so it should have gone to this one. Let's just have a look at timer sub. A, B, time value in B from the time value in A. That's good. If TV diff. Yes, sync. Does not equal error, equate to error. Get time of day. Let's just check that I'm doing get time of day correct. Should just have the default. Got if n does not equal 1. That's very odd. It should have worked. TV diff, TV sec. Okay. Time diff -2. That is not. So That did not seem to match the man page, but who am I to complain? Okay, here we go. In Flash, we're going to get a synchronization error at some point. Come on. Always when you want it to error out, but it won't error out. Come on. Here we go. There we got it. We retried. And we're back. Good. It got a synchronization error and it continued on and it resynced. And of course you guarantee that the data is correct because it has sequence numbers, it has checksums. So a retry will guarantee you get the correct data. Okay. Here we go. We got the same thing again. I mean, it must be. Yep, so it does work. Okay, let's. Whew, this is a bit. It's just It's just insane of how much you got to get this to be. To be reliable communications is not easy. In fact, it's actually extremely difficult with. With serial communications to have reliable data. Okay, so let's do this one to start off with. Okay, so that's good. Let's do out.bin. Okay, here we go. Let's time it, sorry. Let's just check that it did survive that restart, okay. That's good. Okay, so can it dump this serial flash? I suspect it's going to take about 4 or 5 minutes to dump the flash. If it dumps it in around 3 minutes, I think it will be super fast. 2K block size. So we've got one retry. But it seems to have continued on. I mean, otherwise it would just doing retries. So I suspect it will actually go through now and actually be super reliable. I mean, the synchronization happens in both directions. It has sequence numbers, it has checksums, it has retransmits. It is a terrible serial bridge. EC0 commented on the chat that not all serial bridges are created equal, and they certainly aren't. And this, I think, the Node MC is probably the worst that I've tried for a long time. I mean, every conceivable datacomms error you get, whether it's retrans, whether it's duplicate frames or duplicate data, whether it's dropped data, inserted data. Pretty much every possible thing that can go wrong goes wrong in every time you use it. So you absolutely need all this, these layers of checks. So yeah, so it's a slow 3 or 5 minutes when it's when you're streaming for sure. Does anyone have any questions on the chat? It is working fairly reliably now, it seems. It does get the occasional corrupt frame. Every time it does that retry, it has failed to send a frame correctly or receive a frame correctly, or a transaction rather. I'm not quite sure how informative this stream was. It was a pretty hacky go at doing some development, but you know, I think it got there in the end. Even even if you thought about the problem for a bit and you understand how it goes, there's still debugging to do whenever you write code and compile code. Generally, you always know that you'll get there in the end, but there's always a process. I asked if the hardware SPI or software SPI was faster on the ESP8266. Not actually quite sure, so I don't think I'm pushing the hardware SPI much, to be honest. I'm sort of being fairly conservative in the SPI speed, and I'm not quite sure how the software compares. The software one compares to it, and I think at the moment as well, I've just got an actual fixed speed for the SPI on the software Bitbang side, so it's actually not accurately reflecting it. I will get there and implement that at some point in the future to correctly determine how long to delay for between sort of sending out clock pulses for the Bitbang. Okay, so it's still dumping. And without any of those checksums or errors, look at all of those retries. All of those would have been corrupt data if it had just been a continuous stream from dumping SPI. You could certainly dump 8 meg of SPI in one go, in one sort of transaction, but imagine all of that corrupt data that you would get. And the irony is that, you know, I'm assuming the SPI is being read and written to correctly from the node MCU to the flash chip. And in general, I've found that it has, but there's no checksums on the SPI bus. I'm only doing a checksum over the serial comms. Now the assumption is as well is like that I've written the data to correctly in this in this code. So let's just hope I don't get a file of all zeros at the end. And I'm sure it's fixable, but I don't think I want to wait another 5 minutes. Got asked about the memory allocation and deallocation in Flashrom. It's a bit annoying to malloc and free, to be honest, and do dynamic memory management in such a requested sort of such a loop or a state that repeats so many times. So there's actually a lot of allocations going on, which isn't, you know, which I don't really like that much. So I'm not super pleased with it. Potentially I could do alloc A and use it on the stack instead of dynamic memory management. That puts a limitation on the sort of the packet sizes or the frame sizes that you can use. I will show sort of the protocol that I'm using for the serial communication. So this is a frame that gets transmitted with every communication between the node MCU and your computer in either direction. So if the node MCU is writing to the serial comms bus, serial comms line, or the computer is writing to the node MCU, this is the frame that is in every time it happens. Starts off with the command field, just saying what you want the node MCU to do. When the node MCU responds, it should fill out this field, but in general I've sort of been a bit slack, so I wouldn't guarantee that it's filled in every time. The payload length defines how long this particular frame is, ignoring the size of the header. There's a sequence number that increments every time a successful transaction is made, and the sequence number prevents duplication of packets, so you don't process the same packet or frame twice. The checksum is both over, it's a CRC32, and it happens over the header and the payload itself. So, and to do that, you just set the checksum to 0, calculate the checksum, and then write that value into this field. And then you actually have the payload. The payload can be 0 bytes, or it can be an arbitrary length defined on that payload length. So whenever you send commands to the bus side, it'll send, it'll say, for example, detect UART, and then it might pass in particular arguments or variables in this payload section. And that's effectively how it communicates. So to do this Flashrom communication, I'm sending a command to write to the SPI bus. The Flashrom software defines what commands to send to the SPI bus. I just need a way of getting the SPI command over to the node MCU so that it can run it and then get the result. And the flash command, the SPI commands that it sends, it writes some data to the bus and then it reads some data. So that's effectively it. So it might do something like write that I want to read a particular page or address from the SPI flash memory, and then read that many bytes from the SPI bus to get it. And previously, in the very first version of the BUSSide, there wasn't really any framing associated with it. It was sort of just ad hoc, sort of almost text-based communications. The second version had a fixed size frame, and the fixed size frame was about, around a kilobyte in size. The problem with having a fixed size frame is that there's a lot of overhead. So if you send short commands that don't use all that data, then you get a lot of problems as well. And now, in the most recent version, I've made it to be a variable length frame size, and that improves our performance fairly significantly. It is taking a long time to dump this flash. It has surely got to be finished soon. It has surely got to be finished soon. Oh, I think I know. Okay, so EC0's question earlier about using interesting. So okay, now this is interesting. So I've actually done send BB command. Because I'm actually using software bitbanging to implement this SPI flash dumping. Hardware send. So we could actually make this potentially faster by adjusting our SPI speed or using the hardware SPI bus on the node MCU, which is possibly one reason. So let's just look at 1824 times 1824 times 8 divided by 2 divided by 2 divided by 60. I think it was taking about 1 second to dump, to get 2 kilobytes. Okay, so what do? I think the software Bitbang is really slow. Okay, so let's have a look. Okay, I'm gonna replace send bb command. Oh wait up, that looks okay. Send bb command. No, that's it's doing that. Okay. That's not it as well. Send bb fast command. Okay, so let's add some new code. Never ends. We're going to make this send hardware bb command. Okay, so we're going to do that. Get rid of that. I'm going to do void spi dot transfer that's I spi transfer get rid of all of this. And we get rid of this as well. Okay, so we've got a hardware one now. I just think it might take way too long unless I bb hardware. So that was 16 minutes. That's a long time. So I think disconnect BUSSide send SPI command. So software Bitbanging definitely needs some improvement to get those speeds that I need. Yeah, so the flash. So I've got the SPI. There's a comment on this on the Slack. I do have the SPI speed. I'm just and I pass that up into the code for the Node MCU. I'm just not setting my my sort of. I'll show you the code. Oh, I'm not setting the clock delays based on the SPI speed. I'll just have a fixed number in there. I'll get to that. I will get to that at some point. Okay. So let's just check that. That does not seem to be working. Let's just check it again. No. Let's have a look at our fast SPI command. We've got fast command. Got the read size. Here's the hardware send command. What have we got? In got an SPI speed, so I'll use a SPI speed here. Static int. Got our hardware. Let's check. Got to be a bug out here, so out. Not that one. So right size. That looks good. Have I got the SPI pick speed correct? Send, so SPI speed is the first one. And what's our SPI speed? Is SPI speed even set? Eight meg. That's the default 8 meg. Oh, okay, so, yep, so SPI speeds. Speed. Ready, 1, 2, 3. 1, 2, 5, 1, 2, 3. 250, 2, 3. 1, 2, 3, 1, 2, 3. SPI speed, SPI speed. I think I just got the SPI speed wrong. if we can get it working now. Yep, that's good. Okay. Whew. Back to this one. Let's just add I just want to see if we've actually improved the performance. Now when it was sending out about 1 2K block a second. So if the hardware SPI at a good speed, we should start to see this hopefully. Yeah, okay, that's super fast. Yeah, so okay, that's much faster. So that would have been going at printing those lines at about 1 per second before. So I can certainly increase the speed of the Bitbanging for SPI Flash, but I don't want to start a new sort of project. Okay, so here we go. Now, will it take 5 minutes? It's at 8 meg, the SPI speed. Okay. Okay, so hopefully now we get this done in a few minutes, not 2 days. So if this dumps in a few minutes, I'm calling it quits, and I'll enjoy the rest of my afternoon out in the sun, having a beer, having a wine, knowing that I've got made some progress on the bus side. Now, ironically, the Bitbanging seemed like, is it just me or is it not getting as many errors? Which is sort of makes no sense in any way. Like why it's not retrying. It's just random serial comms, I think. I'm not quite sure. Or maybe it'll just be the same amount of errors as before. Flashrom, I sort of was negative about Flashrom in the past, but having looked at the code a little bit more, it's actually not too bad. It's actually quite good that you don't have to implement everything yourself on the bus side. You just have to implement pretty much one command, that is to run an arbitrary SPI command and read the data on the bus, and that's all you have to do. And then a Flashrom takes care of everything else. It's actually quite good in that sense. And in fact, Flashrom has better, faster write support to Flash than the bus side client does at this point in time, because I don't implement some of the more optimized commands for Flash memory. There was a good comment actually about why there's less errors on this time running, possibly less electromagnetic interference between serial and SPI pins. Now that's interesting actually. That's a very interesting, yeah, it is interesting to see how you can reduce the noise that goes onto this, yeah, very interesting. Probably good that I was doing Bitbanging in software before, so I got more errors and saw more failure cases. If it works under bad conditions, it will certainly work under good conditions. Come on. Hurry up. Oh, Oh, it dumped it. Let's have a look at just a quick look at the out.bin. And yes, that looks like a good dump of the flash memory. If we run binwalk on this now, yes, we see an image. That was pretty fast. That was under 4 minutes with 4 errors using Flashrom. That's pretty good. And I think if we optimize the size of the blocks to read, at the moment it's 2 kilobytes. Maybe it should be 4 kilobytes. And maybe that will improve performance because there won't be as much overhead. Okay, so it works. And I think to me, I think it's going to be pretty reliable. I think a fair bit of engineering has gone into making it reliable. And I think at this point it's going to be pretty good. So dumped it in 4 minutes, three and a half to 4 minutes, and I'm pretty sure we could get that lower to maybe about 3 minutes with better use of block sizes. There's a trade-off, of course, between bigger block sizes is going to have more errors, but that's pretty good. I'm pretty happy with that. So thank you very much. Thanks for the guys who actually stayed on the Twitch stream and were chatting at the end. I think it's good. I mean, I'm not quite sure if people find development interesting, but this is actually not that uncommon. The sort of the process of wanting a feature or having an idea and going and implementing it. And normally they take a few hours. Sometimes things take half a day or a day. I generally don't like to leave my code base completely broken when I sort of pack up. So I try to pick manageable tasks that can be done in an afternoon or at most sort of a day. So thank you very much. Go to the website infosec.cbr.com.au, do some training on interfacing with IoT devices using the BUSSide and some of our other toys. So I'll see you guys next time. Thank you.